Hi there, Mr. Chan here. I'm about to do lesson 1-3 called Solving Equations with a Variable on Both Sides for Algebra 1. Please turn to page 9 of your note taker, the Student Companion, and let's get started with the opener here. Some friends want to see a movie that is showing at 2 different movie theaters in town. They plan to share 3 tubs of popcorn during the movie. As you can see from this little diagram, we have ticket prices in a table, but they want to buy 3 tubs of popcorn. I'm going to go ahead and multiply each of those values off to the side by 3. And any chance I get to draw a picture, I take it. Why not? There we go. We want 3 tubs. And having a calculator would be handy. I will be multiplying theater A's popcorn by 3 and theater B's popcorn by 3 as well. When you do that, you'll get these 2 numbers respectively, $17.25 and $20.25 for theater B. That's a great place to start. When we buy that, we want to also add in the ticket prices. So, which theater should the friends choose? Let's go ahead and create a table to help us sort this out. Theater A, theater B. We just found out how much 3 tubs of popcorn cost for each of the theaters. I'm going to write that down here as well as over here. We're going to add on ticket prices. Notice that the popcorn in theater A is cheaper, but the ticket prices are a lot more. You can always add on to the table. If you brought one friend and you, that would be 2 ticket prices. So when you add 2 ticket prices for theater A, you are adding $29. $29 is doubling the $14.50. $29 plus $17.25 will give you $46.25 for 2 friends, you and your buddy. Likewise, for theater B, we're going to go ahead and put that in. We're going to add $26 for 2 friends. 2 times 13 is 26. And that added to the 20, 25, crazy enough, will also give you the same exact price in theater A, $46.25. So this is interesting. Buying 3 tubs of popcorn shared amongst 2 people is the same price, but what would happen if you keep going? That's the question. Which theater would be cheaper? Well, at this point, it's obvious. If you tack on $13 for theater B, for 1 additional ticket for a friend, versus 1 additional ticket for a friend in theater A, that would be more expensive there. So here, theater B is cheaper with 3 or more people. In theater B. Yay. Very interesting. Second question, for what situation would the total cost at each theater be exactly the same? Oh, we kind of got lucky there. That answer we did already, and that is when you have two friends. With 3 tubs of popcorn. For a total price of $46.25. Next question. There are 2 different methods to solving this problem. What do you think is the best and why? We use a table. We can use a spreadsheet, like Excel or something. Or we can just manually add that we did in some parts of this problem. To be honest, I don't really know which one's the best way. It's whatever you're comfortable with. Let's switch to the next page. Let's skip the bottom one there. All right, here we go. So the name of this section is called Solving Equations with a Variable on Both Sides of the Equation. Variable is usually x. Sometimes there are other letters, but these first 2 examples are pretty challenging. I'm going to pull the one from the book and write it off to the left-hand side. Here it is. These equations are pretty hefty. 3x minus 10 plus 4x equals to negative 2 times x minus 4 plus 9. If you're following in a book, this is the problem on page 18, the textbook. Now the problem with the variable appearing on both sides of the equation is to try to combine like terms before you try to solve the equation by undoing operations. First thing I want to do is divide up the problem in half and see if I can combine any terms. If you see on the left side, there are a couple of terms that can be combined together. 3x and 4x are like terms. 3 of those plus 4 of those, of course, is 7 of those. On the right side, we have something interesting. We have the variable x buried inside the parentheses. I would highly recommend that you apply the distributive property from negative 2. So negative 2 times x is negative 2x. And negative 2 times negative 4 is positive 8. Oh, look, 8 and 9 on the right side can be combined together. Let's go ahead and do that. And of course, that gives you 17. All right, we still have the variable x on both sides. Strategy is to move the smaller term to the other side. In this case is negative 2x. The opposite of that is to add 2x to both sides. So right now I'm combining like terms on the same side, and if I need to move terms to the other side, I apply the opposite operation. 7x plus 2x is 9x. On the right side, I'm only left with a 17. Look at that, almost finished. I'm going to go ahead and start solving for the variable because now the variable x is ready to be isolated. And to do that, we need to undo operations. Just a quick reminder, we are going backwards of PEMDAS. Adding, subtracting are first, so I'm going to get rid of the minus 10, not the times 9. The minus 10 is the highest priority. Let's move that to the other side or make it a 0 pair. If I do it to one side, I got to do it to the other side. Oh, look, 17 plus 10 is 27. All right. Divide through by 9 to both sides. And we get a nice answer of 3. The other two problems involve decimals and fractions, but the situation is pretty much the same. Apply the distributive property when necessary, and combine like terms, and ultimately move all the variables to one side and solve for that variable by moving everything else away from it. Let's go ahead and apply the distributive property on both sides. Look at that. 100 gets distributed to the first pair of parentheses, and the negative 10 is applied to the second pair of parentheses. Let's write down the result. It's getting a little cramped. Let me give myself a little vertical line, kind of separate everything. Now this is a part where you might struggle if you don't have a calculator or if you can't think about how decimals are multiplied. 100 times 0.2 is basically minus 20. On the other side, we get negative 10 times 5 is negative 50z. And negative 10 times 0.8 is minus 8. Not too bad. We have z for my variable. I need to move one of the terms to the other side. I'm going to move the smaller one, which has to be negative 50, z. Opposite of negative 50 is positive 50, or add 50 to both sides. Let's do that. Clean it up. And the rest, now I can undo operations and solve for z. Got to get rid of the minus 20 first. Got to do it to both sides. Watch out for those negative signs. Negative 8 plus 20, opposites subtract. 20 minus 8 is 12. Carry the sign of the larger number. That happens to be positive. Last step, divide by 150. Once in a while, we'll get a fraction. That's okay. Make sure you try to reduce. Let's see. Think of the greatest common factor that divides into 12 and 150. That happens to be 6. 6 will go into 150. Now, if you didn't get there, you're always welcome to reduce it manually by small numbers like 2s and 3s and 4s and 5s. In this case, I will do that and divide by 6, tops and bottoms. When I do that, I'll get 2 over 25. All right. Another equation to solve involving fractions. I'm going to attempt to distribute the 5/8 because I notice that the number 16 and the number 24 inside the parentheses are multiples of 8. So when I distribute, those fractions will reduce. So I'm setting this up for reduction. All right. I'm going to distribute the 6 as well. I wish that they didn't use the letter D because it's easy to confuse D's and 6's or B's too much. So 6D minus 6 plus 1. All right, let's reduce those fractions. Let's see. That's technically over 1 there, and that's technically over 1 over there. 8 goes into 16 nicely, twice. 5 times 2D is 10D. Nice. In the second fraction product, let's reduce that. 8 goes on 24 3 times. 5 times 3 is 15. And I'm going to go ahead and combine -6 and 1 together. That gives me -5. Hey, not too bad. The fractions came out really nicely. I'm going to go ahead and continue combining like terms because the letter D is on both sides. I'm going to move the smaller one to the left-hand side. Whoops. Technology, what can you do? So when I move the 6D to the side, I'll get 4D plus 15 equals -5. Let's go and undo operation to solve for D. Subtract 15 to both sides. Ooh, watch out for this one. -5 minus 15, same sign. You add the numbers, carry the sign they both share, and then finally divide by 4. Ooh, a -20 divided by a +4 is a -5. Quick recap. We did order of operations. We also did combining like terms. Some things that you might want to practice. All right. The next example will result in some strange answers. Let's explore that. Example 2. Understand equations with infinitely many or no solutions. Kind of interesting. Let's go and proceed and solve these. Identify the variable. In this case, on example 2a, it's the letter T. This is deceptive, so be careful. On the right side, I have a negative sign that needs to be distributed to the parentheses. So -27, and then on the back half, negative times a negative is a positive T. Okay. On the left side, I'll bring that down. Now this is kind of interesting. The letter T shows up in 2 places, but something strange happens when you try to subtract T to both sides. The strange thing is that the variable T disappears. Oh no! So I need to put a little star here, a little disclaimer, and say the variables disappear. So what do you do now? Well, look at the answer you just got and ask yourself, is that a true statement or is that a false statement? -27 does definitely equal -27 after the variable disappear. This is considered to be a true statement. And because this is a true statement, the answer is anything will work in this equation. Meaning any number you pick is a solution, so we write down infinite solutions. That symbol looks like a sideways 8, refers to infinity. You're also welcome to write down all real numbers if you want to. But ultimately, we also identify literally this is an identity. Any number will work in that equation. The second one's kind of interesting. There are some fractions involved with the distributive property. Fine. Let's go ahead and crank through. The 16 times 4 is 64. 16 times -3m is -48m. All right, that takes care of one side. The other side, 96 and the 2 does reduce to 48. 48 times negative m is negative 48m. Interesting. And 96 times 1 is plus 96. The variable is m. Let's go ahead and move one of them to the other side. By adding 48m to both sides. All righty. Oh, the variable disappears again. Oh, goodness. But the statement itself is a false statement. 64 doesn't equal 96. When this is the case where the variable disappears, nothing will make this equation true. The answer is no solution. Okay, that's it. All right, let's skip the bottom question. That's not on our final. Next page. All right, mixture problems are out this year. Let's go ahead and cross that out. Don't worry about that. But we do need to answer this question right here under habits of mind that kind of goes with the example 2. How can you determine whether an equation has infinite, many, or no solutions? When you try to solve an equation, the variables disappear. All right. Example 4 is something that's not on the final. Let's go and skip that. And let's jump to the last page. If there are any questions, please ask. But the last page just involves solving some problems. And it's pretty straightforward. Let's do it. All right. Okay. Some more solving with the variable on both sides of the equation. Let's get through this. Number 5, the variable is x. Oh no, they're on both sides. I need to kind of break that 2x out of the parentheses. One way is to apply the distributive property with the 5. Let's do that. 5 times 2 is 10x. And the second half of the distributive property is 5 times 6 is 30. Nice. Bring down the other side. And I need to move x's around. Always pick the smaller one and move it to the other side. Let's move the 8x to the left side by subtracting. That gives me a 2x plus 30 equals 48. Aha, we can now undo operations. Don't forget, please excuse my dear Aunt Sally, backwards. I like to write that down, kind of remind me of what to do. Let's go ahead and decide whether to move the 2 or the 30. 2 is multiplying with the x. You leave that alone. Multiplication is not the most important. 30, of course, plus 30 is the most important. Let's go ahead and move 30 to the other side. Opposite of plus 30 is minus 30. That leaves me with a 2x equals to, 16. Then, did I count that wrong? Aha, I did. That should be an 18. Sorry about that. Last step, divide by 2. Yay. X equals 9. Ooh. Any questions? Number 6. I'm going to apply the distributive property with -3 first, and that's it for that side. Nice. -3 times 8, negative times a positive is a -24. And -3 times the back half, positive 3h is -9h. All right, variable h is what I'm trying to combine because they're on both sides of the equation. I'm going to move the smaller one to the other side. Now this is going to be different. This time I'm going to move the term on the left side to the right side. You got to be flexible in terms of solving from either side. 5h plus 9h is 14h. And the rest is solving by isolating h. You can't get rid of the 14 first because that's not the most important thing. You got to get rid of the 4 next. Subtract 4 to both sides, according to SADNet. That's just backwards of PEMDAS. That leaves me with a 14h equals to, be careful here, -24 minus 4, same sign, you add the two numbers and carry the sign they both share. Just writing out in the white space, I'm writing out a space here. Last step, divide by 14. Yay. H equals -28 divided by 14 is going to be a -2. Woo! Almost done. How's everybody doing? Number 7, we have y's all over the place. Let's crank through that. Wow. We got a double distributive property, one on one side, one on the other side. That kind of reminds me of one of the examples that we did earlier. Let's go ahead and clean that up. 2y for the first product minus 2 times 6 is 12. On the right-hand side, 3 times y is 3y, and 3 times -4 is -12. There are y's everywhere. I might as well combine like terms on the right-hand side. Don't do opposites, it's not necessary because they're on the same side. You just go ahead and combine them together. 3y minus a single y, which technically is a 1y. 3 minus 1 is 2y. Oh, interesting. Look at the y's. If I subtract y to both sides, the variables disappear. Oh no. Put a little star here. Variables disappear. So ask yourself, your result that you get, is that a true or false statement? In this case, it's a true statement. Which means this has infinite solutions or all real numbers. And in this case, we call it identity. You pick any number in the whole world and that problem number 7 will work. All right, last one here. I think I'm going to skip the word problem at the bottom. It's not necessary. You can look at the notes online. They have number, I'm going to write that down. See notes for number 9. Number 8, I have a feeling what's going to happen. All right, distribute the 2. And we get 8x minus 8. Bring down the other side. Ooh, the 8x's go away. We have a similar situation. We obviously know that -4 does not equal to -8. This is a false statement. Doesn't make sense, does it? So that means there is no solution. All right, what do you guys think? Another section down, huh? I'm going to go ahead and stop the recording. I hope you enjoyed that. Have a nice day.